Afternoon. We're a pleasure to be able to present some aspects of the Jamaica Mangrove Restoration Project. I'm Terrence Forrester. I'm the manager for this project and really regret not being able to be there with you in Colombia, but that was unavoidable. So for the next few minutes, I want to update those of you who are already familiar with the project and bring into the picture those of you who are not knowledgeable about the project. And if you track my cursor along the coastal forest, about 100 kilometers of it, it's about 3,500 hectares. And these orange areas, large orange areas, add up to roughly 50%, a little bit short of 50% of the total area. And since 2004, they suffered dieback. With the DEFRA funds administered by IDB in 2021, we brought on board an excellent consulting firm, contractors, Coastal Dynamics Limited, and together we have executed this project. The approach is common sense, assessing the site characteristics by detailed measurements from the sea all the way up to the catchment areas. And with that understanding, try to make up our minds exactly why the mangroves died. Based on that baseline assessment, and the ideas about the cause of die-off, to develop a restoration plan, and then where we are now, to implement the nature-based solutions that will restore the mangroves. These are the 10 kind of critical data gathering steps that led to an understanding of the baseline characteristics and the die-off, and which ultimately underlay and underpin the restoration plan. Literature review, of course, satellite surveys, aerial photography using both LiDAR and optical, coastal monitoring studies, including beach profile, wave climate, tidal excursions, meteorology, hydrologic monitoring from all the way up in the catchment area, right through the river basins, and then, of course, complemented by the tidal inundation, flora and fauna, both terrestrial and aquatic, carbon stock assessment, above and below ground, socioeconomic assessments, and then using modeling studies, numerical modeling, to hypothesize based on all this baseline information, including inputs from the community that have very valuable historical insights, hypothesizing which nature-based actions would reestablish hydrology principally, and so allow for the spontaneous regeneration of the mangroves. Those big three contributors to dieback are tropical storms, which changed the topography, especially the beach profiles, and silted up historical channels that brought seawater in and out. Changes in land use, the 20,000 hectares here for about 400 years was in sugarcane. Flooding irrigation was the method used to water the plants, and therefore for 400 years there was a lot of water, fresh water going in the back. Sugar started to die in 1970-something because of changes in trade preferences, and completely died in 2019 with the closure of the last remaining factory, and therefore fresh water from the back ceased. Other changes in land use, including the establishment of an aquaculture shrimp farm here in one of the areas, roads across another area here, as well as here. Together with the historical references and recollections of the community, we added published events, and so put together a fairly comprehensive understanding of the steps towards the death of these mangroves. This is one example, the same shrimp farm. So in 2003, when the shrimp farm was being established, you can see nice healthy mangroves here along the coast. But 2 years later, the mangroves appear to have died back. And that dieback lasted through the closure of the shrimp farm in about 2012, all the way up to when we started looking at it in 2021. And so they are today. Some pictures recapitulating what I just said. So LiDAR based on this matrice DJI, optical on this smaller DJI, and the LiDAR, of course, giving this kind of elevation model from sea level where the mangroves are to increasing elevations as you get into the transitional areas. It's important to note that tidal excursions are less than a meter here, probably 0.7 to 0.8 of a meter. Tidal gauges set out to sea and a weather station. Beach profiles done manually. Sediment transport along the coast following the drift, the sediment availability, wind speed and direction. Characterizing flow through some of the major rivers, 3 of them, Milk River, the Rio Minho, which this is, and the Salt River, by getting the cross-section and then measuring the speed of the transport of water in this cross-sectional area. And we have a permanent radar observation that continues to track the flow through at least one river. Water and soil sampling, as I said, the catchment area all the way down, using wells and riverine observation posts from the National Water Authority. Soil sampling, both coring for below ground and standard measures, DBH and height for trees. And then over the entire area, LiDAR for canopy. Flora and faunal assessment, both aquatic and terrestrial, were performed for obvious reasons. And this really kind of gives a flavor for the serious and continuing engagement with the community. Here in a participatory GIS workshop, we had members from the community over a full day come in and add their understandings and their ideas about what went wrong and what could possibly be done to improve it. Those weren't the only group meetings. We had focus groups. This is a fisherman's group, Fisherman's Beach. And these are fishermen here looking and doing pretty much the same thing with the maps. And of course, the SES survey, house-to-house surveys. And so where we are now is that we understand, we're pretty good understanding why each of these areas, nuance by area, died. We have restoration plans that have been established. We have conceptual engineering and we have detailed engineering, barring the last bit of tweaking so that the precise excavations can take place. All permits are on hand. And really all we are doing now is waiting for the IDB approval to actually begin the restoration. I'm going to comment on one area, not go through all 4 areas, just to show the application of some of the restoration planning. So here you see Boggy Pond, Mangrove Area 2. And what you're looking at here is the coastline, and you're also looking at a historical channel that was blocked that in 2019 as a pilot project, we dredged and allow the seawater to enter and get back out. This is the direction of the currents.
Okay, I found this on the web for seawater. Is the direct?
Sorry about that. That's AI out of control. In addition to that, this road here, which had been put down by the community in order to access this beach, had completely blocked the flow of water westwards. We had a pilot culvert here, and between the 2 of them since 2019, there has been significant regrowth in this area, which had looked pretty much like this before. In this area, what is planned? What is planned is a supplementation of the culverting across this road based on the volumes indicated by the numerical modeling. And so we're going to put on 3 additional culverts across here and dredge the channel that was opening and slightly reorient it with a view to keeping it open better. So first steps, about a year and a half ago, prior to funding hiatus, we cleared one of the channels that will conduct storm runoff water into the mangrove. There's another one here that needs to be cleared. as I said before, put 3 additional culverts sized to conduct enough water to improve the hydrology, and 3 dredging this channel. So no hard structures apart from the culverts, which are meant to reestablish hydrological connectivity. The timeline, well, between 2022 and 2024, we did baseline surveys, restoration plan, engineering. There is a funding hiatus that's almost completed now. We've done the design and are about to do the construction between August, this is now August, and November. And of course, defects notification period, the monitoring phase. Challenges. There are lots of minor, small problems to solve over the 4-year history of this project. And perhaps 3 challenges worth mentioning is 1, the risk management plan excludes extreme weather events. During the restoration phase itself now, during the ensuing monitoring period required long-term for the regrowth of the forest, and there's no current solution for this. So it's a big risk. The funds that are available are insufficient to implement the full restoration plan. And with this in mind, we are looking for additional funding that would chip in when the current project ends in March. And security concerns were a little bit greater than we had anticipated, requiring a close collaboration with the Jamaica Constabulary Force. And this has essentially mitigated the risk to the personnel in the field. And in fact, the Jamaica Constabulary Force their community branch is really very well integrated into the community. So thank you very much. Apologies for not being able to take questions, but of course, I'm sure email and WhatsApp, we can cover those. Really grateful for the opportunity, and good evening.